Hello everyone. In this video, I am going to explain about the sequencing circuit on a hydraulic system. First, I will explain how the sequencing circuit is working. Then I will explain about how to simulate the sequencing circuit by using AtomSim software. Okay, let me see one by one. See here we have a sequencing circuit. Sequencing is nothing but how to operate or how to do the work one by one by using the either single acting or double acting cylinder. In this circuit, we are using two double acting cylinder, right? And how the two double acting cylinder forward and external retraction can be achieved by sequence based on the requirement. Say for example, the sequencing is nothing but if you consider these two cylinder, first cylinder A and cylinder B. Cylinder A extends, then cylinder B extends. Thereafter cylinder B retracts, then cylinder A retracts. This is the sequence of this circuit actually. Based on that, we can design the circuit. For designing the particular circuit, what are the components to be required? Any kind of hydraulic system, we need a power pack which consists of a reservoir, a filter, and a hydraulic pump with motor and a pressure relief valve. Okay, this is called a power pack, and we need a directional control valve. It may be a 4x2 or 4x3 directional control valve based on the requirement. If you want a ideal position, you can choose 4x3, 4-way, 3-port, 3-position directional control valve. If you don't want a ideal position, then we go for 4-way, 2 positions directional control valve. And we need a two sequencing valve. One is for each cylinder, one sequence valve is required. In this sequencing valve, check valve is the integral part of the sequencing valve. So sequencing valve consists of a pressure relief valve as well as the check valve. So each cylinder consists of one sequencing valve. That means we need to operate each cylinder. We need one sequencing valve. Okay, so parts required to design this circuit is on reservoir, that is on power pack, which consists of a reservoir, filter, pump with motor, then a pressure relief valve, then on 4x3 or 4x2 directional control valve, two sequencing valve, and two double acting cylinders. Okay. Now, how the circuit is working? See here, first pump will pump the fluid. The hydraulic fluid is stored in the reservoir. While pump is working, the fluid is sucked from the reservoir through filter. Then that pumped fluid is sent to the directional control valve. Here there are two positions. One is straight position and another position is cross position. Okay. If you engage by this operating lever, it may be a manually operated DCV. By operating this lever, straight position takes place, first position. That time fluid is flowing through this port, through this line, and it will enter to the cylinder A at this side. Okay, so that the piston will extend. Cylinder A extends. Same time, fluid is entering this direction also through this sequence valve. Here, this sequence valve having the entry and exit Also here you have one check valve. Okay. So there is a pilot line also, which is also connected with the supply of fluid, supply line. So fluid entering here will enter to this check valve. Check valve is in opposite direction, so fluid will not enter through this way. Okay. Then it will enter to the pilot line also initially. So fluid will not allow to enter in this sequencing valve because the spring force is high compared to the fluid pressure. So it will not enter this side also. Again, this will enter directly to the sequencing valve. So due to the spring force, the valve is initially in closed position. So flow is rejected or not allowed through this sequence valve initially. So all the fluid is flowing through this way to the cylinder A. So cylinder A extend. So extension of cylinder A takes place. When the cylinder A piston fully extended, then the pressure inside the cylinder is increased. Due to that increasing pressure, the negative pressure is generated in the supply line. So due to this negative pressure, it will come back through the same way and the pressure will increase in this sequencing valve. So what happened due to this pilot line, this will push the spring up so that the sequencing valve will open now. Same time, fluid back pressure is going this check valve also. It is already in opposite position, closed position. So fluid will not flow in this direction, opposite direction. So all the fluid will flow through this entry line, I mean inlet of the sequencing valve and come out through the exit. Then through this way it will go. So that cylinder B extension takes place. So cylinder B extension takes place only after cylinder A extension is completed. Right? Then once that extension is over, we have to shift this, change the position of directional control valve by operating this manually operated DCV. By changing this position, now the cross position is takes place. Okay. So while cross position takes place, what happened? Fluid is flowing through this line. Same as like a previous uh, step. Fluid is flowing this direction also this direction. So now it's entering in a cylinder B. What happened now? Cylinder B piston retracts due to the supply pressure of a fluid. Same time fluid is entering in this sequencing valve, but it's already in closed position initially due to the spring pressure of the sequencing valve. Okay, same time the fluid is flowing in this through this check valve also. It's also in opposite direction, so it will not allow the fluid to go that side. So now fluid is entering this pilot line also. Due to higher force of this sequencing valve, fluid will not enter. Once that cylinder B fully retracted, then back pressure created on this side of cylinder B. That back pressure will come back through this line. Then that time it will go back to the sequence valve again. That time through this pilot line, pressure is increased. So the spring force is less compared to this back pressure. That time this pilot valve will open. So the fluid will flow through this sequencing valve and entering to the cylinder A in this passage, this way. So cylinder A retracts now. Once it is completely retracted, then we have to change the position either in ideal position or again straight position. So this will be repeated based on the operation. Say for example, for what application we are using the sequencing circuit is, say for example, we need to hold the workpiece and first hold the workpiece, and next operation is say for example drilling. Okay, for drilling operation, first we need to hold the workpiece, then we need to drill the workpiece by drill bit. So drill bit may be attached with the cylinder B. For clamping purpose, we are using cylinder A. So first initially we have to clamp. So cylinder A extends. Then cylinder B extends. During cylinder B extended condition, drilling operation is performed. After completing drilling operation, we have to bring back the drill bit again. So cylinder B retracts, then unclamp the workpiece. So cylinder A retracts. This is the sequencing circuit operation. Now we will see how to simulate the same circuit using AutoSim software. I will open the AutoSim software now. Let me see. Open the AutoSim software. Here you have a hydraulic actuator. For designing the sequencing circuit, we need two double acting cylinder. I will select two double acting cylinder. Okay. Two double acting cylinder. Then you have a directional control valve. I am choosing 4/3 directional control valve. Then in hydraulic, we need a sequencing valve, which consists of a pressure relief valve and a check valve. Two pressure relief valve, two check valve. Right. Then we need a hydraulic pump with motor and a reservoir. There another filter. So double click this. Here you have a option to change this symbol as a filter. So filter, I will bring that. Then it is a motor. Okay. Then we need to attach the pressure relief valve. Then we will connect this line to DCV. Here return line is connected to the reservoir. Okay. If you want to monitor the supply pressure, attach one pressure gauge here. So pressure gauge attached. Now, as per the circuit, the inlet of inlet exit from the directional control valve is connected to the inlet of the cylinder. There is no sequencing valve. Only return line we have to connect the sequencing valve in cylinder A. Right. So I will directly connect this with the supply. Okay. Now this sequencing valve I will connect I modify this sequencing valve because it's only one entry. Okay, I will modify this also. Notice here there is a pressure of 6 bar. We'll set that as later. Okay, so this pressure leaf valve will open at 6 bar pressure. This is in closed condition, opposite direction. I will change this direction by means of left click. Here there is option rotate 180 degree. Here also I will rotate 270 degree like this for my convenience. Here we need to customize this DCV. Double click this. So I am going to customize this as a push button operated or manually operated lever type spring. This side also one operating lever and spring operated. Okay, center position. See, left side is cross position. I want to cross position is in right side. Left side is straight position. Cross position right side. So I customized the DCV now. So return line we need to connect the is the sequencing valve. Right. Return line I am going to connect. Okay. Same time from a supply line, another connection is there to return line. Sorry, it's cylinder B, no? So I will connect this line. I will invert this, rotate this 180 degree. Okay. So connect this line with supply. Okay. So connected with inlet of the cylinder B. Here this connection is connected with exit of cylinder B. So connect with this. Same time this will be connected to the second sequencing valve, and output of the second sequencing valve is connected to cylinder A. That's it. Now connection has made as per the circuit. Now we will check whether it is working or not. Give this go button. Okay. Now we will see. See here the delivery pressure of pump is only 6 bar. Only 6 bar. If it is enough, then it's working. in the same pressure. So I want to modify the delivery pressure. See, this pressure relief also works. Check the pressure relief valve pressure first. We'll stop this circuit. So pressure relief valve will work open on 6 bar pressure. I'll set that as 10 bar. Okay. So this also 10 bar. Is also 10 bar. And the pump also 10 bar. So all will open and pressure increases 10 bar. What happen now? If pressure increased in supply line 10 bar, all pressure relief valve will work. If less than that, fluid is flowing in another way, right? So what I can do is check now. First, we will check how it's work. Otherwise, we have to increase this pressure relief valve pressure. If supply pressure is equal to the pressure relief valve pressure, then fluid is flowing directly to reservoir. So I can modify this. First, we will check pressure is up to 10 bar. So I will shift this DCV to cross position, right? So first cylinder extend, then next cylinder B extend. I will change this position now. Cross position. So see, it's not working because pressure increases. All cylinder, sequencing valve pressure is 10 bar only. This pressure relief valve pressure also 10 bar. So excess pressure will be released here. So no fluid is flowing through this. Okay. So that what we do, first increase the pressure, relief valve pressure. I'll set that as 15 bar. Okay. Now we will check how it's performing. Now it's retract, right? So I'll change this cross position. It's retract. Straight position. So cylinder A first extend, then cylinder B extend. I'll change this position, cross position. Now it's an ideal position. Ideal position, all fluid will come to reservoir. I change the cross position, right? Okay. So the circuit is exactly working. If you want to measure the entry pressure of cylinder A and cylinder B, add some more pressure gauges here. That's all. So this is the way we have to synchronize, check that sequencing circuit by using the automation software. Thank you.